let's do this. How many moves do we need? Think about basic operation, right? When we do analysis, we need to count the number of basic operations. The operation is one move. One disk move is one basic operation. So let's count. How many moves do we need to solve a problem of size n? Yeah. Okay. All right. Let's still use recursion, because the function recursion. Okay, the basic operation move a disk from one peg to another. Very simple. Let's define the count function C of n. We don't know how large is this function, but we can do recursion. Based on the recursion, we can get a recursive formula, recurrence relation about C function. Okay. Look at this. In order to get number of moves for disk size, number of disk n, we need to solve a problem one fewer size twice. So that's why 2 times C of size n minus 1. And an extra move. The bottom disk, one move. Okay, we add to it. So we get this recurrence relation with, here I should put 1. Yes. 1, okay, I will change. Base case, not that n, okay, base case. When n reduced to 1, it's trivial, so we stop, okay. All right, so how to find the solution? How to find explicit formula for C of n function? So that's we need to do some math. Okay? We need to find a smart way to find a solution. Okay, all right. So, how to solve? Okay. Here, we need to use some math operations. So, what kind of math operations? So here, transform the formula. If we work on this formula directly, it's hard, right? So we have the situation. So this situation we will have frequently. When we work on a particular formula, it is very hard. In this situation, you should think about how do you transform the formula, change the form. Okay? Equivalent form. You do the form, this equivalent formula. You get equivalent formula, but the formula form looks very different. So you can see some insight. With a new form, you can find some insight of the problem. Then you can solve it. Okay. So let me show you how to do it for this equation. Okay. All right. When we start, so let's examine this form. What property does it have? Okay. The structure. I mentioned that structure. Structure is very important. You need to explore the structure, both sides of this formula. Left-hand side, right-hand side, they have different structures. Okay? They have different structures. So we want to explore the similarity of the structure. Similarity. Similarity, that means the left-hand side, right-hand side, they should have the similar structure. That we mean the similarity. We want to explore that part. If they do not have similarity, we try to make that similarity. Then, similar structure, then it's easy to solve. Okay? So how do we get that similarity? Okay. Look at this. Right-hand side, we have this +1 term. But left-hand side, we don't have that +1 term. Right? That's different. That's the key difference. Now we want to make up that key difference. Yeah. We don't want, we want left-hand side, right-hand side you have a plus term. Let's add a plus term to the left-hand side to make them look similar. How about that? Okay? So let's add 1 both sides. How about that? Yeah? Because right hand side you have plus 1. I also make left hand side plus 1. Okay? So let's add 1 both sides, but 1 plus 1 you have 2. Okay. After you make that change, it's an equivalent, right? Equivalent formula. So that's what I mean, transformation. Like this. Okay? Take 2 out. After you take 2 out, you see plus 1, right? Left hand side plus 1, right hand side plus 1. Are they similar? So from their structure, they are similar. They have a similar structure. That's good. Okay? When they have similar structure, then we have some easy way to, to find a solution. Okay? So after we compare, they have similar structure. How about we define a new function, d of n equals c of n plus 1. We can define a new function. Okay? If we define d of n function, this becomes d of n minus 1. Okay? Yeah. We want to simplify the equation. After we introduce this d function, we simplify the original equation in this way. Okay? Like this. Plus 1 is gone. See? In this new equation, that plus 1 term is gone. Right? Is it easier to solve? Right? No plus 1. Okay? Only d. So when you increase the size by 1, from n minus 1 to n, you just multiply by an extra 2. Okay? That's simple. All right. Now, let's reduce the size by another 1, multiply another 2. Okay? All right. Yeah. Right. Because d of 1 equals 2. Yeah. d of 1 equals c of 1 plus 1. That's why d of 1 equals 2. Okay? d of 1, based on our definition, c of 1 plus 1. c of 1 equals 1. So that's why d of 1 equals 2. Okay? The base case. All right. Now, yeah, let's replace d of n minus 1 by 2 times d of n minus 2. So 2 squared n minus 2. How about that? Okay? All right. Can you get d of n equals 2 to the nth? Can you get that? 2 to the nth? Can you see that? Yeah, because d of n minus, you can use this formula another time, equals 2 times d of n minus 3, and so on. Can you finally reduce to this number? If you cannot see, so let me show you one way to see it. Okay? Yeah. All right. Can you see this? Can you see this? 2 to the n minus times d of 1. Okay? If you cannot see, let me give you one way to see it. Yeah, because we will do this kind of thing many, many times in this class. So I want to give you one way to get it. Okay? Now, all these steps, we want to keep track of all of them. Okay? I introduced an idea called invariant idea. In math problem solving, there is a very important idea called invariant. Find the invariant. Then you can solve many tricky problems. Invariant. What's the invariant? Okay, yeah, let me explain this invariant idea. When you do the form change, yeah, you need to keep doing form change. Okay, keep doing. First we have this form, then we have that form. We change this function in many different forms. When you do many form change, try to explore which quantity is invariant when we do all the changes. You do many changes, but there is one thing that never changes. One quantity never changes. That is the invariant. We want to find that invariant. Then it's easy. Let me tell you, what is the invariant? 2, the exponent is 1, right? 2 to the first. Exponent is 1. 1 plus the problem size, what's that number? N, right? 1 plus n minus 1, that's n, okay? Remember that number n, okay? Exponent number 2, 2 plus n minus 2, what's that number? Also n. So the exponent number plus the size number, that is invariant, okay?
Wait, how is n minus 2 equal to n?
Look at this exponent. Exponent 2, size n minus 2. 2 cancel out. You get n, right? The sum is invariant. Sum, okay? Look at the sum, okay? We just look at the sum, okay? All right, the sum invariant. Sum invariant. When you do all the way, the sum should be invariant, okay? That's our invariant, all right? When we reach the bottom, this situation, exponent n minus 1. And because the sum should be n, here it is 1, okay? 1, the size 1 plus exponent n minus 1, the sum is n, invariant, okay? We use that invariant to guide us. So we always, when we do the form change, long sequence form change, we always stick to that invariant. So we cannot go wrong, okay? We cannot go wrong. So when we reach the bottom, the last case, we know what are those numbers, okay? This is 2, all right? 2 times 2 to the n. Okay? That's the invariant. Later I will use that invariant many times, okay? To get used to this idea, invariant idea. Okay? Yeah. All right, so now we find d of function equals that one, then easily c function minus 1. D function minus 1, we get a c function. So c function explicit formula, 2 to the nth power minus 1. That's the answer. Okay? Yeah. So here you can see, this is a simple recurrence relation, pretty simple. Yeah. But when you solve it, okay, how many techniques do we use? Okay. First, transformation. Okay. That's something not very easy. Okay. After that, when we do this, invariant. Okay. 2 big ideas. Okay. Transformation, exploring similarity in structure. That's first big idea. Second, invariant idea. Then you can solve it. Okay? Yeah. So I like you, practice. Yeah. Okay? Yeah. I like you to do some practice. Yeah. Because I already assigned homework assignment number 1. So I do not have chance to assign you another homework before test 1. But I want to give you a chance to practice this solving the recurrence relation like this. I want to give you a chance to solve it. Okay. So the only way I can do that,
Can you just give an example?
quiz number 2. Remember, I give you a quiz. So I put this question, one of the quiz questions, before the test. We can do a quiz because we have total 4 quizzes. So before the test, I do another quiz. But this quiz, I give you a take home. So I give you a take home. Okay? So, not in class, take home.
Can you give us some examples in the book where we can try to do something by ourselves before we get the quiz?
So you need another example? Okay. Another example? All right. Yeah. Yeah. So I can give you some examples. Yeah. Yeah. Let you practice a little bit, then you do a quiz. Okay. All right. Then, all right. So before we move to next topic, here I remember there is a very nice story I remember when I saw this example before. When I was young, I heard the story related to this puzzle. Yeah, it's like you know chess, right? The chess. Okay. Who invented chess? You know that? I mean, Indian. Yes, as I know, Indian invent chess. Okay, so then I remember. So there is an Indian king, playing chess. So then there is a smart guy, someone very smart. Okay, yeah, I forgot the name. Yeah, but someone really smart. So that smart guy playing the chess with the Indian king. Okay, yeah.
And with rice.
Yeah, with the rice. You know the story, right? The rice. Yeah. So, but because they bet some, win, lose, they bet. So that smart guy said, if I win, you just give me rice. Count the number of, yes, right, the square. The chessboard, there were 64 squares, right? The first square, just put one rice piece, one rice on it. Second, double. Third, double again. Every next square, you double it. Okay? Then, after you cover the whole board, then I just want them much rice. Okay? So you can see total 2 to the 64 minus 1, number of rice. 2 to the 64. But if you calculate how much that amount, that's overwhelming, 2 to 64. Okay. So the Indian king cannot have that much rice. Yeah. The whole earth, there is no such amount. 2 to the 64. So that gives you how large is 2 to the 64. That number, how large it is. How large this move. Now, if you solve, this is 64, how large that number is. Okay? Yeah. Huge number. Yeah. All right.